Okay, let's look at a problem here where we have a geometric sequence has the following terms. A1 is equal to 4, A2 is equal to 7, and we want to find A5. So let's find the fifth term in the sequence that starts with 4, 7, and then it's got some things that we don't know, and then we need to find the fifth term. Okay, so first things first, we need to find the common ratio, which we are always going to just write down as R. And we want to think, okay, I know that A1 multiplied by something, this R, is going to give me A2, which is telling me that 4R is equal to 7, which just means R is equal to 7/4. Don't write this as a decimal. You could, sure, but just leave it as a fraction. It's way better. So we've got this R is equal to 7/4. And we, of course, know that A1 is equal to 4. And so AN, our general term, is going to be equal to A1, that first term, multiplied by R to the n minus 1. And so in this case, AN is just going to be equal to 4 multiplied by 7/4. Let me undo that. 4 times 7/4 to the n minus 1 power. So if we're in a situation where we want to figure out A5, well, that's not too bad. We're just going to, plug into this formula, but plug in n equals 5. Okay, great. So this is equal to 4 multiplied by 7/4 to the 5 minus 1. So we got a lot of 4s showing up in here, and maybe that's not the best thing in the world, but it's okay. And so A5 is equal to 4 times 7/4 to the 4th power. Now, you'll notice I actually say A5, and maybe some people sometimes will, be really careless with their language and they'll say, they'll phrase something like the following. They'll phrase something like x squared, and they'll say x2, and I go, no, you can't do that because x2 is, of course, this, which is a subscript. And so, this is sort of like a situation where we're noticing the importance of having a distinction there. It's not a to the power of 5, it's A5. It's the fifth A. It's the fifth term in this sequence. Okay, so you could just leave your solution like this, and I encourage you to actually do that. I encourage you to just leave it as 4 times 7/4 to the 4th power. You could simplify it if you really wanted to, but I would not bother. This is a perfectly acceptable final answer. Now, the next kind of thing is a really similar question, but we want to incorporate, a little bit of a harder problem. So let's say we had the geometric sequence where A2 is equal to 3, A5, so the fifth term is equal to negative 81, and we're trying to figure out A9, the ninth term here. All right, so we don't know what A1 is, and we don't know what R is. Let's find R first. Let's find R. Let's find R, which is the common ratio. And what we know is that A2 is equal to A1, which is unknown, times R, which is also unknown, but to the 2 minus 1 power. So this is A1R. We also know, I'll put like a little bullet point there, we also know that A5 is equal to A1 times R to the 5 minus 1, which is A1R to the 4th, obviously. Now, we know what A2 and A5 are, so what we could say is we could sort of say this is equal to negative 81, and this thing up here is equal to 3, and we're going to do the following trick. We're going to do A5 over A2. We're going to say A5 divided by A2. Well, luckily we know both of those, so it's negative 81 over 3. And if we plug in these two things right here, this for A2 and this for A5, we can get the following fact. We can get that A1 R to the 4th divided by A1R is equal to this negative 81/3. Well, negative 81/3 is actually doable. That's just negative 27. And we're going to use our rules of rationals. The A1s are going to cancel here. And we have r to the fourth divided by r, which is just r cubed. And so negative 27 is equal to r cubed. Hopefully this is one where you can figure this out, just by thinking about it, or you could take the cube root of both sides. So we're going to do negative 27 to the 1/3 power is equal to r cubed to the 1/3 power, which is of course just equal to r. And negative 27 to the 1/3 is negative 3. Okay, so we have r, which is the most important thing. So our common ratio is negative 3. And then we're just going to sort of plug this back into probably this equation right here, because that's the easiest one. So we're going to recognize that a1 is equal, or a1 multiplied by negative 3 is equal to 3. And so a1 must just equal negative 1. Great, we have our explicit formula then. We have a1, we have r, we're good. So we can say, all right, I know that an must therefore be equal to negative 1 multiplied by negative 3 to the n minus 1. And if I'm trying to specifically find this ninth term, which was the thing that I was originally presented with, all right, it's a9, or the ninth term of this geometric sequence is negative 1 multiplied by negative 3 to the 8th power. I do not want to actually do 3 to the 8th. That seems really annoying. But we do want to kind of consider the signs here. And we're going to notice this is a negative to the 8th power, so that's going to become a positive. And this is just going to be times negative 1, so it'll be a negative times what will ultimately be a positive, giving us a negative. And so a9 is going to be equal to negative 3 to the 8th, where I am intentionally not having parentheses around there. Honestly, if you leave it like this now as I'm doing it, I'm like, oh, this is, if you're someone who messes up your negative signs all the time, honestly, if you leave it like this, that's fine. But this is just a little bit nicer down there. Okay, so that is, kind of doing an example where you know a couple of terms and you got to find the common ratio, and then using that, you're going to go back and find your first term.